Hello, hello, hello. Hello, am I audible? Yes. Very good afternoon, everyone. So, we are in the week 11 of the Geotechnical Engineering 2 coursework. Over here, we are studying the different aspects of the application of the geotechnical engineering in the practical life. And we have started with the understanding of the shear strength. As we move ahead, we understood the different type of test associated with the shear strength. And as we have already studied the 10 week of this coursework, so we are in the week 11, and as the course name suggests, the geotechnical engineering 2. Over here, we are understanding the aspects like the shear strength. After that, we have understood the earth pressure in the shear strength. We have understood the different type of tests like direct shear test, triaxial test, vane shear test, and many more. Apart from that, we also solve the question associated with the same. In the previous 3 or 4 classes, we have understood the aspects of the earth pressure, that is the active earth pressure, passive earth pressure, and earth pressure in rest condition. As we are going ahead, now we will look into some of the more aspects of the slope stability, and as it is the week 11, and as per official we have the 12-week coursework, but I am taking one more course. So the next week, on the Monday only, there is a 12th class, and as scheduled, regular 13th class will be takes place on the Saturday in the coming week. And the next week, one day class will be going to take place from 12:30 to 2:30. So, as per your availability, you can attend online in that time as well. If not possible, you can go across the video on the YouTube, which will be shared with you afterwards. Okay. So some instruction before starting the today class, that the video which the presentation which we are presenting, and the video lecture will be shared with you by the NPTEL team through the YouTube link, and the presentation what I am presenting will be shared with you. The Google Drive link is already shared with you, and that will be the place where I will upload this presentation file, whatever I am going to text the class today. Okay, so we are going to understood some of the aspects of the bulkhead sheet piles, which we have gone across in the previous class, and in addition to that, we start the slope stability, which we will finish in the upcoming class that is going to take place on Monday. And afterwards, one additional class I have managed to take place on the next Saturday in the same time, that is 3 to 5. So over there we can discuss some more aspects, some questions related to the concept which we are maybe lagging and which might be help you in the examination of the certification which you are going to take in the after the 23rd of October, whatever the date will be. So I planned the thing in the same way, and we can discuss some more problem whatever we have studied throughout the coursework, and we will proceed in the same manner. Okay, so with this some more points I want to connect you that as the presentation and video will be shared with you, and if some internet connection problem or anything else, if my call get disconnected, please be remain in the meeting. I will rejoin and take the class from there only. Okay. Okay, so now I'm starting the content for today. So first of all, starting with my introduction. My name is Sumit Kumar. I am PhD research scholar at IIT Islamabad. This coursework named is Geotechnical Engineering 2, which is taught by Professor D.N. Singh sir. As you have gone through the Geotechnical Engineering 1 or maybe the soil mechanics coursework earlier, so you come to understood that the different aspect of the geotechnical engineering soil mechanics, you come to know that the what are the property, how to calculate the unit weight, what is the density of soil, how what is the porosity, what is the void ratio, and many more things, and their application which we are taking in this coursework. So up to that, when we have started with the shear strength, we understood that why shear strength is too much important for us. If we know the shear strength of the soil, what are the different aspects we could see from starting from the first class only. I have said that whatever we read, we need to understood that what is the importance of it, because if we are read anything, some importance would be there. If we no importance of anything, why we are taking any course? So in the same aspects, I have taken the all the content. So I think so you will be gained some knowledge with this coursework up till now. So we are moving ahead with the bulkhead concept in this class, and in the this class only during the second session, that is after 1 hours, I will take the slope stability part, and which will be carried forward on the next class that is going to take place on Monday, and some problem will also be solved over there. So we will see that what are the things we are going to take. Okay. So this first of all, starting with the bulkhead concept, that is the anchor bulkhead, are the retaining walls that are used to prevent the soil erosion and to provide the area suitable for docking. Anchor bulkheads basically typically constructed by driving the steel seat piles. As we have understood that when we are going ahead with the seat piles, we have understood that that can be made of the different material, maybe steel, maybe wood, or maybe concrete. They are temporary as well as permanent, and where it is permanent, where it is temporary, we have gone across in very detail in the previous class. And the tie, this is a tieback system, can be made up of the steel cables, rod, or strip. You see in the image coming ahead. Okay, so anchor bulkhead are used in the variety of application. What could be that application? So the waterfront construction, yeah, obviously river bank stabilization, highway and railway construction, land reclamation. So over there, specifically if some structure, some work is going in the for the construction of highway or the railway, over there the anchor bulkheads are created to sustain the soil mass over there. If some land property improvement takes place at some soil improvement techniques are implemented over there, also the anchor bulkhead plays an important role. When we talk about the components, some components must be there of the anchor bulkhead. So the first component is nothing but the seed piles. The seed piles are the vertical slots that retain the soil. As you see, the seed pile, we have read the seed pile, and we have understood, developed the understanding that the seed piles sustain the soil mass, sustain the water in the different aspects. Whenever any construction work is going on, we have understood that during the construction of some earthwork is going on over there, a temporary seed piles walls could be constructed. If some bridge are constructed and their piles are under construction, over there also we use the seed pile walls. So in the same way, the seed pile is one of the most important of the anchor bulkhead. The second one is the tiebacks. The tiebacks anchors the seed piles to the ground. Third is the waller. The waller is a horizontal beam that connect the top of the seat piles. Basically, we have understood that in the seat piles, it is a watertight as well. So connection is very much important. If the connection is not as much inherent, then there is no point. There will be some leakage, and if it sustain the water's body, then the water flow into that section. So that is of no use. That's why the horizontal beam is used to connect the top of the seat piles to provide strong connection between them. The next one is the coping. Coping is a cap that protect the top of the seat pile wall from the erosion. The next one is the gravity bulkhead. Gravity bulkhead rely on their own weight to resist the lateral pressure from the soil. Cantilever bulkhead rely on the tie back system to resist the lateral pressure from the soil. Now, what are the types of anchor bulkheads? That is the gravity and the cantilever. Obviously, the gravity bulkheads rely on their own weight as to resist the lateral pressure from the soil, and the gravity bulkheads are typically used in the shallow water application. Similarly, the cantilever bulkheads rely on the tieback system to resist the lateral pressure from the soil. Cantilever bulkheads typically used in the deep water application. It is opposite of the gravity bulkhead. Gravity bulkhead is used in the light water application. Over there, the depth is less, and in the cantilever bulkhead is in the deep water. As the gravity bulkheads rely on their own weight, so that's also one of the reason. And in cantilever, the tieback system is used to support them. Okay, now we discuss the design of the anchor bulkheads depend upon. So it depend upon the type of soil, second depth of the water, third is the height of the bulkhead, and the next is the surcharge load on the bulkhead. Okay, now you see that the construction of anchored bulkheads. So how the construction process proceeds. So the construction of the anchor bulkhead typically involves the following steps. And what are those steps? Those steps are that the seat piles are driven into the ground, then the tiebacks are installed. Afterwards, the waller which we discussed is the beam which connects the top of the seat piles is connected to the top of the seat piles, and afterwards the coping is placed on the top of the seat piles. Okay, as we go ahead, we see that the design of the anchored bulkhead, so the seat piles are driven into the ground, tiebacks are installed, the waller is connected to the top of the seat piles, the coping is placed on the top of the seat piles, and the design of anchor bulkheads is proceeded. Now, talk about the advantages of the anchor bulkhead. If we are using the anchor bulkhead, there must be some advantage because from the very first class, the purpose and the advantage and disadvantage are the very most important aspects whatever we have going across. So, some of the advantage related to the anchor bulkhead that they can be installed in a variety of soil conditions. So if the soil conditions are typical soil conditions, some difficult soil conditions over there, the construction practices will be difficult. Over there also the anchor bulkhead are installed to prevent the flow of soil from one section to other section, so the work could be proceeded very easily. They can be installed in the confined spaces if the space is very negligible, very small space are there at any specific section. Over there also they could be installed. They have a high load bearing capacity, and they are relatively quick and easy to install, as it is discussed in the case of the seat pile wall as well. So when we go ahead and when we talk about the disadvantages, there must be some disadvantages of the every system which we are using. So they can be expensive to install, and they require a regular maintenance and inspections. They are susceptible to corrosion as they are made of steel, so the corrosion chances will be more. And in the bulkhead, the sheet piles which are used is are of the steel in the most of the cases. That's why the chance of corrosion is one of the most important factor, and its cost, its implementation is easily. If the space are limited over there, also we can install the anchor bulkheads. But the cost, the skill manpower is required, the transportation cost of those sections, and many more aspects, the engineering aspects make it expensive to install in the soil wherever we are keen to do so. Okay. Now, the benefits, as we have seen the advantages, we see the benefits. The benefits of using the anchor bulkhead is that they can be installed in a different type of soil and they can be installed in the confined spaces. What are the advantages? Is also the benefit. It is just for revision purpose. They have a high load bearing capacity over there. We have not mentioned this. They can withstand a very large amount of load and they are relatively quick and easy to install. This is already covered in the advantage of the anchor bulkheads. Now, the disadvantage we have gone across already that it is expensive to install, require regular maintenance, and the inspection is the one of the new point which we have added over here, and the susceptible to corrosion is also covered all as before only. Now we talk about the applications. So applications also we have seen earlier that the waterfront construction, river bank stabilization, highway and railway construction, land reclamation. Some slides are repeated, so not to worry. If it is repeated, it is well that you get the revision of the same for the two number of time in this class only. So those things remain with you as you move ahead. Okay. Now we talk about the history. Anchor bulkheads must have some history how it started. So anchor bulkheads have been used for over 100 years. It is a very long ago this type of techniques has been started. So the first anchor bulkheads were built in the late 19th century to protect the coastline of Europe and the North America from erosion. As we have seen that the river stabilization, some of the application which we have seen, the waterfront construction. So over here, this case study is viable that the first anchor bulkheads are used to build coastline of the Europe and the North America, and this is takes place to protect them from erosion. Okay. Okay, so now we see that the anchor bulkheads were also used extensively in the construction of the Panama Canal in the early 20th century. So the two of the application, two of the example which we have seen across over here is the example over the river. First is the protection from erosion for the protection of the coastline, and second one is the construction of the Panama Canal. So those both are associated with the water body. So the as we have seen the two of the examples over there in which we have mentioned the application, that is the waterfront construction and the river bank stabilization, both are covered, right? Okay. Now you see that now we talk about the types of tieback system. If we have studied that the tieback system are used for the cantilever bulkhead, so the some are the types of the tieback system which must be associated with it. Okay, so the passive and active tieback systems will be there. When we talk about the active tieback system, they rely on the tension in the tieback to resist the lateral pressure from the soil, whereas in the passive tiebacks rely on the friction between the tieback and the soil to resist the lateral pressure from the soil. So these are the mechanism through which sorry, these are the mechanism through which the transfer of forces takes place in a cantilever bulkheads. Okay. Now we see, as we move ahead, we again see the design process of the anchor bulkhead we have seen. But some of the points over there is not covered will be taken over here. So first of all, the site investigation is the one of the most important aspects, because when the site investigation takes place, we came to know the engineering behavior, geotechnical property, whatever the site have, the basic property which we have gone across in the geotechnical engineering course 1, that is the density. We perform the different tests like the SPT test, so we know its plate load test, bearing capacity we came to know. We perform what is the maximum tide density, what will be the optimum moisture content. So by performing the site investigation and performing the different type of test associated with the soil, we came to know the property of the soil. Hence we are able to answer the very suspect that what type of engineering we require to process the anchor bulkhead at that site. Afterwards, the structural analysis, that the structural engineer perform the structural analysis to determine the load that will be applied to the bulkhead, because if the bulkheads are constructed as we have said that they have the high load bearing capacity, but some engineering aspects also need to be taken care of, because it is not like that we provide the bulkhead and it will take care of any amount of load. So what amount of load we need to sustain with the bulkhead, in that order only we are going to construct the bulkhead material, the property, its thickness, and many more things. So the structural analysis is performed. Okay. Afterwards, the structural engineer will design the seat pile wall to resist the lateral pressure from the soil and the surcharge load. Surcharge load could also be there as the bulkheads are installed. Afterwards, the design of the tieback system takes place, in which, as we have as we have already said, that the tieback systems are used for the cantilever bulkhead. Over there, the active and passive two type of tieback systems are there. So, in designing of the tieback system, the structural engineer or the professional will design the tieback system to resist the lateral pressure from the soil and to anchor the seat pile wall to the ground. If it is not anchored, how it can sustain that much load? So that is very important. That designing is one of the most important aspect in the design process of the anchor bulkhead. Afterwards, the preparation of the site takes place. The site is prepared by cleaning the area of debris and leaving the ground for the construction practices for the bulkhead installation. Now, the process of the anchor bulkhead consists of preparing the site. Is and first of all, the site is prepared by cleaning the area of all debris and the leveling the ground. As we have gone ahead with this, now drive the seat piles. The seat piles are driven into the ground using a vibratory hammer and a hydraulic hammer. As the one question arises during the previous class, whether the hydraulic hammer are used, the three options are there in which we are discussing. So I have also doubt in that class, but the hydraulic hammer is also used to draw down the seat pile wall. Okay, the third one is the installation of the tie bags. So the tie bags are installed using a variety of methods such as the drilling and grouting or jetting. And as we go ahead, the construction of waller and coping. So the waller and are connected on the top of the seat pile, as we already said it is used to connect the seat piles, and the coping is placed on the top of the seat piles as well. Now, you see, when we talk about the history of anchor bulkhead, we have said it is a 100-year-old technology which we are using from a very past time. So, first of all, the driving the seat piles. The seat piles are driven into the ground using a vibratory hammer or a hydraulic hammer. Then the tiebacks are installed using a variety of methods such as drilling and grouting or jetting. Then the waller is connected at the top of the seat piles. So, in this case, when the pile driving test takes place, are performed to ensure that the seat piles are driven to the correct depth and they are properly embedded in the soil. Then the tieback load test take place. In this stage, tieback load tests are performed to ensure that the tiebacks can be tested the design load. Then the welding inspection are performed to ensure that the welds between the seat piles and the boiler are sound, so that their connection are established in a true sense. When you talk about the cost is very most important thing, as we have already read in the disadvantage that they are susceptible to corrosion, they are expensive, and it is also a possibility that due to its expensiveness, its use could be limited. So the cost of the anchor bulkhead vary depending upon the number of factors, including the size of the bulkhead. Obviously, how much load it need to resist, the soil condition, and the depth of the water, and the construction of the anchor bulkhead can disrupt the marine ecosystem, and can lead to the loss of habitat for fish and other wildlife. Anchor bulkhead can also reflect waves and the currents which can erode the beaches and damage the coastline ecosystem. So those are the most of the important aspects. As we have already seen, the two examples, one is in the application in the 19th century in the Europe and the American region over there, it is used to protect the coastline. In the second, in one canal over there also the bulkheads are used. So if they are installed, they could affect the marine ecosystem over there in one way or the other. They could, they must not, but whenever some artificial applications are used to protect the coastline or protect the erosion, we might disturb the natural ecosystem which is established for the animal over there. As we have, you have gone through the environmental course over there. Also, you see that some of the applications of flow of water, like cleaning of water, means that takes place that lead to the die of the fish in a specific region. In a similar manner, over here also, if we provide the seed pies, there might be a possibility that the marine ecosystem over here, fishes and some other plants which may be below the sea level takes place may get affected. So that is also one of the case. And the anchor bulkhead can reflect the waves and the current which erode the beaches and damage the coastline ecosystem. That damage the coastline ecosystem. Okay. Now we see the quality control and the testing of the anchor bulkhead. So the quality control and testing is an important part of the construction of the anchor bulkhead. The following tests are typically performed to ensure that the bulkhead is constructed correctly. The first is the pile driving test. In a pile driving test are performed to ensure that the seat piles are driven to the correct depth and they are properly embedded in the soil. Second one is the tie-back load test. In a tie-back load test are performed to ensure that the tie-back can withstand the design loads. The going forward, we see welding inspections. So the welding inspections are performed to ensure that the welds between the seat piles and the roller are sound. As we have seen these aspects, these connection types, these components of the embedded of the bulkheads which are used in the gravity bulkheads, which are used in the cantilever bulkheads earlier as well. Right. Now we talk about the environmental implementation of the anchor bulkhead. As we already know, it could affect the marine ecosystem in a way. So, what are the other impact which these anchored bulkheads can could create? We are going to see that. Okay. So, the anchor bulkhead can have a negative impact on the environment, like the construction of anchor bulkheads can disturb the marine ecosystem. Yes, and can lead to the loss of habitat of the fish and the other wildlife, as I already said. And the anchor bulkhead can also reflect the waves currents which erode beaches and damage the coastline is one of the most important aspects. Okay, some case study as we have read Panama canals already. The two more case study are also mentioned over here. So we will go one by one and we see that the construction of the anchor bulkhead could what could they create a problematic situations for the ecosystem which are situated over there. So first of one is the Panama Canal are constructed in the early 20th century. Anchor bulkhead were used to support the canal walls. The anchor bulkheads at the Panama Canal are some of the largest and the most complex anchor bulkheads in the world. Okay. So over here in the case study, we are presenting the sites over there. The anchor bulkheads applications are taken place. So the Panama Canal is the one of the case over there. The anchor bulkheads are used during the construction. Going forward, the second one is the Golden Gate Bridge. The famous Gate Bridge was constructed in 1930. Anchor bulkheads were used to support the approach ramps to the bridge. The anchor bulkheads at the Golden Gate Bridge are some of the most iconic anchor bulkhead in the world. Yes, as whatever the case study we are reading, you can go on the Google and search. Over there, you can find some very good images, some very good pictures. Over there you see that their applications how it takes place. Maybe if you go across the YouTube, you can see some of the videos which are explaining the anchor bulkheads application on these sites. The next case is the Hoover Dam. The Hoover Dam are constructed in the 1930 as well, and the anchor bulkheads are used to support the dam abutment. The anchor bulkhead at the Hoover Dam are some of the most important anchor bulkhead in the world as well. So I will suggest that you can Google these images and see that how their construction takes place, and maybe some of the videos you could find at the some other platforms like YouTube regarding the same. Okay, so that much from my side for that. Now we will conclude this section and we move to the next section, because as per our schedule we are keen to complete this section in the previous class only, but as we have go into detailed discussion of the topic during the last class, so something left behind which we are covering today. And as the next one is the slope stability, which is a very easy thing, so not to worry, and the things will be covered by the next lecture. Everything will be completed on Monday, and Monday 12:30 to 2:30 will be the class, and afterwards we will in the final class, which we used to schedule at Saturday, will take place on Saturday from 3 to 5 only in next week. Over there we will cover the entire syllabus for a one time, so that revision will be there for you. Okay, now we will conclude this section. So, in conclusion, we say that the bulkhead can be installed in a variety of soil conditions. They can be installed in a confined spaces. They have a high load bearing capacity. They are relatively quick and easy to install. And these are the some of the most important aspects. Anchor bulkheads are versatile and effective retaining wall solution. They can be used in a variety of applications and can be installed in a variety of soil conditions. However, it is important to note that the anchor bulkhead can be expensive to install and require a regular maintenance and inspection. This is also one of the disadvantages when we have gone across the advantage and disadvantage section. So over there in conclusion, these points are mentioned here with this. Uh, we have almost concluded the anchor bulkhead. Now we see some more point about the cantilever seat pile walls. So in the construction design of cantilever seat pile walls, first and most important point is the site investigation. Engineer will perform a site investigation to determine the soil condition and the groundwater level. As I have said again and again from in this overall coursework, that water is the biggest enemy of the soil. If the water table is not there, the 50 to 60% of the problem associated with soil will be eliminated. So we need to take care of that in a soil investigation. And in the design of the seed pile, engineer will design the seed pile to resist the lateral pressure from the soil and the surcharge load. Then the person will prepare a construction drawing and show the layout for the bulkheads, and the detail of the construction will be there. Now, as we see the lateral earth pressure based seed pile was, so for that we say that the lateral earth pressure is a horizontal force exerted by the soil or the other material against a retaining structure. It arises due to the natural tendency of soil to move and redistribute when subjected to external load. If load are applied, the load will try to be distributed. Soil try to move in a certain direction, due to which this tendency create. When we talk about its importance, specifically in our civil engineering domain, so the lateral earth pressure is a crucial in a civil engineering, as it directly impacts the design and stability of the retaining structure like walls, foundation, and embankment. When we develop the understanding and managing the lateral earth pressure is essential for constructing safe and durable infrastructure. As we see the overview of the presentation which we are going with, So in this section, we are going to cover the fundamental of the lateral earth pressure, various theory related to it, design consideration, types of written structure, and a specific focus on the breast sheet pile walls. So starting with overview, there are the two primary theory used to understand the lateral earth pressure, that is the Coulomb earth pressure theory and the Rankine earth pressure theory, which we already discussed as well in the some of the earlier classes. Over here, we see some of the glimpses of that, and we move ahead. So this theory provides the foundation for the designing retaining structures. The first Coulomb earth pressure theory which we are discussing is based on the concept of the active and the passive earth pressure, which depends on the angle of internal friction of soil. It helps engineers to calculate the lateral forces acting on the retaining wall. The second one is the retaining earth pressure theory, sorry, unkind earth pressure theory, in which take account both the angle of internal friction and the wall friction between the soil and the retaining structure. It provides more accurate prediction of the lateral earth pressure and the wall stability. When we talk about the type of retaining structure, so retaining structures are the engineering solution used to support the soil or the other material to prevent them from collapsing or sliding. They are essential in the various construction infrastructure projects. When we compare the breast sheet pile with the other sheet piles, so the breast sheet piles are the distinguished from the other retaining structure by their use of the seat piles combined with the bracing system. Unlike the gravity wall, sorry, or the cantilever wall, base sheet piles rely on the external bracing to resist the lateral earth pressure. Some of the common application of the braced sheet piles are the sheet piles are commonly used in the waterfront structure to control erosion, protect against flooding, and provide stability for excavation and foundation. Right. When we conclude this section with the key component of the bed sheet pile wall, we say that the first one will be the structural component which is associated with the bed sheet pile wall consists of the sheet piles that act as a primary structure. These sheet piles are typically made up of steel. They form the core of the wall. Moving ahead, we say that the bracing system will be there to provide the lateral support to the seat piles. As we see, the bracing system should be active or passive. The tie active tie bar or passive tie bar, how they transfer the load through tension and through the anchorage between the ties and the soil. In the passive case, they include valves, studs, and the tiebacks or the anchor which help to distribute and resist the lateral force. And the tieback and anchors are the crucial component that anchor the wall to the stable soil or rock. They prevent the overturning and the sliding of the seat piles. When we talk about the facing material often made up of the concrete, timber, or the steel provide protection and aesthetic to the wall surface. Okay, now we talk about the design consideration for the braced sheet pile wall. So the factor influencing the design is the first point, and the going ahead, the design consideration include the soil properties, wall height, external load, groundwater condition, and the project specific requirement. The load calculation and the structure analysis is the next point, and the engineers calculate the load that wall must resist, including the lateral earth pressure, water pressure, and any additional external loads. The soil mechanics and the geotechnical aspects will also be taken care of in the design consideration of the braced sheet pile wall. Afterwards, we are able to develop an understanding for the soil properties such as the bearing capacity, settlement characteristics are some of the essential designing parameters for making a stable braced sheet pile wall in the field. Okay, now when we talk about the lateral earth pressure distribution, we say, okay. So we are left with some of the slides before we sum up this section, and then we move ahead with the next part, that is the slope stability, which we keen to do so in this class. Okay, so the lateral earth pressure distribution. So first of all, the explanation of the lateral earth pressure distribution. Then the lateral earth pressure varies along the height of the wall, as we already know that as we go deep down in the gamma h sections get valued, and it includes the active earth pressure pushing the wall outwards. As we already know, when we talk about the active earth pressure, the wall is moving away from the soil mass. Over there, the stress in the soil get reduced. Over there, the maximum principal stress in the vertical direction, and the minimum principal stress in the horizontal direction. Similarly, the second case is the passive earth pressure, in which the wall is pushing inward, in which the wall is moving towards the soil. We discussed this thing in very detail, and in that case, the maximum principal stress in the horizontal direction, if we relate it with the shear strength, which we have read, specifically the triaxial test things. So in that case, the wall is moving towards the soil, so that will create aspect in which the active maximum principal stress acting in the horizontal direction. The next one is the rest earth pressure, in which the no movement is permitted, and the distribution depend on the factor like the soil property, wall friction. So as we have said that as we go deep down, as we vary with the length, as we go in lengthwise, maybe soil property vary, like the stratified soil layer will be there, like the property of the soil above or below a specific distance will vary. So that will result in a different type of earth pressure. Okay, now we talk about the braced seat pile wall design. So the designing the braced seat pile walls involves selecting the appropriate seat pile type and size, determining the bracing arrangement, and addressing the drainage and the seepage control to ensure the wall stability. Now, as we talk about the types of bracing system, so the bracing system provide the essential lateral stability to the braced seat pile wall. They include cantilever bracing, strut and tie backs, and the anchor bracing, each with its advantage and the application. Now, when we talk about some of the case study, so case studies show that the real world example of the best seed file wall project, and they provide the practical insight into the application of the breast seed file walls in the various construction scenarios. As we go ahead, we talk about the construction and installation. So, the construction phase of the breast seed piles include the process involves the phases such as the excavation, sheet pile wall installation, assembly of the bracing system, and backfilling. As first of all, we create the site. Afterward, the excavation takes place to insert the seed piles. Then the seed piles are installed at the site, and then we remove the seed pile to make arrangement to insert the seed pile wall. Then afterwards we do the backfilling at the specific site. The proper sequence and the safety measures are also very much important during the construction and installation of the seed piles. When we talk about the safety measure, it includes the measure to protect the worker, prevent accidents, and ensure the integrity of the wall throughout the construction. When we talk about the case study on the installation process, so the case study illustrates the step-by-step installation process of the breast seat pile walls, highlighting the specific challenges faced and the several strategy employed over here. Now we see the monitoring and maintenance in a through a phase diagram. So starting with importance, so the regular monitoring is crucial for detecting the early signs of distress or instability in the wall. It helps to ensure the long-term structural integrity. When we talk about the maintenance consideration, so maintenance tasks include the routine inspection, repair of the damaged components, and addressing any drainage issue. As we go ahead, we talk about a well-maintained wall, prolonged its lifespan, and reliability. When we talk about the protocols associated with inspection. The inspection protocol outline the uh, procedures and criteria for accessing the condition of the breast sheet pile wall, including the measurement of the anchor, tension, and the wall alignment. Right. Now we talk about the environmental consideration. So impact on the surrounding environment. So the construction and the presence of the breast sheet pile wall can affect the natural environment, including the water flow, vegetation, and the wildlife habitat. The consideration of these impact is very much crucial. As we talk about the erosion control measures, the implementation of the erosion control measures such as planting vegetation or installing the sediment barriers can mitigate the environmental impact of the breast sheet pile walls. And the compliance with the environmental regulation will result with a local and a regional natural environmental regulations, and often necessary permit is essential to ensure the responsible construction practices. It is very much important because environmental aspects during the construction practices, the after the safety, the environmental aspect is very much neglected across the world. If you talk about our country also, these things is quietly largely viewable. So we need to be a little bit aware in that directions in order to prevent our environment from getting harassed due to the construction practices. The rule and regulations should be followed in order to prevent our environment from getting damaged in such conditions. Now, when we talk about the safety precautions, so safety measure during the construction. So, during the construction, the safety measure includes providing the proper personal protection equipment to the worker, ensuring the excavation safety, and the conducting the regular safety benefits. When we talk about the long-term safety consideration, the long-term safety consideration involves maintaining the anchor conditions, inspecting bracing system, and addressing the potential hazard like corrosion or erosion. Corrosion is also one of the hazard as we are talking about the seat piles. Over there, the erosion is one of the aspects, and corrosion is one of the important aspects. When we talk about the compliance with the other occupational safety standards, so the compliance with the other occupational safety standards and the guidelines such as those provided by OSHA, the agency, is a crucial as well as critical to protect the worker and ensure a safe construction environment. Right. When we talk about the cost consideration, the factor affecting the cost, several factors impact the cost of the breast sheet pile wall projects, including the design and complexity, choice of material, labor cost, and any required geotechnical investigations. As we see, the budgeting for the breast sheet pile was project. So the budget involves estimating the project overall cost, including design, material, construction, and contingency. So accurate budgeting is essential for the project planning. And as we talk about the cost benefit analysis as well, because during construction, the cost benefit is one of the most important which the professionals should also look into in that direction. So, a cost benefit analysis help to evaluate whether the benefit of the constructing a bridge sheet pile wall, such as the flood protection or the stability, overweigh the project cost over its lifetime. So, those things need to be taken care of. When we talk about the future trends and the innovations, we find that the emerging technology may include the use of the advanced material, innovative monitoring system, and automation in the construction process. So, sustainable practices is retaining wall design may involve the green wall solution, eco-friendly material, and the design that minimize the environmental impact. As we see, the research and development is going in this area, so that may include improving the wall material, enhancing the construction method, and optimizing design for increased efficiency and suitability, as well as sustainability. Okay, now we will conclude. So, in conclusion, we say that emphasizing the importance of understanding the lateral earth pressure, proper design construction, monitoring and environmental consideration, importance of the properly designed and maintaining the best seed pile was. So stress is the significance of the wall design and the well-maintained best seed pile wall in ensuring the safety, stability, and protection of the infrastructure and the environment. Encouragement for the future learning. So the people, the investigators explore the additional resources and continue to learn about the complexity of the breast, seed pile, wall, and the retaining structure. Okay, so we are going to the slope stability. So over here we will take a small 5 minute break, and then we come ahead and start with a new thing. Okay, so 5 minute break will be there. Okay, so I will see you after 5 minutes. Welcome back. Okay, so we will move ahead over from here. Um, okay, so now we are moving into the topic named slope stability. Hmm. Over there, we will see some aspects related to the same. That what are the understanding we are getting from there, and we will proceed in that direction similarly. So, as we have know that talk about slope. So before that, you understood that in our country only, the various slope failure takes place over the years, and that will lead to the huge loss to life and property. So it is very much important for we civil engineers and geotechnical experts need to look into those factors that how to prevent the damage of the structures which takes place during the various slope failures across the globe. So, what the thing which we could look into and we could perform in order to ensure the safety of the slope. So, as we know that our country diverse and there is lot of chances that the various failures takes place due to some of the um, some of the earthquakes sometime or many more things. So, how to prevent the chances of damage which occurs throughout the world and our country could be reduced with the contribution of mm, you and me is very much important. So those aspects which we are going to take place during our study in a slope stability. Right. Okay, so now I am going ahead and we will see that what are the most important point which we are keen to discuss during this session, and we will also develop the understanding about the same, and not today but in the next class we are going to discuss some of the important things like the problem associated with the same, that what are the questions which could be there regarding the concept which we are going to discussing today. So we are specifically focusing on the infinite slope rather than the finite slope during this session, because a lot of the natural slopes which we came across in real life is the infinite slope. The finite slope should also be there, but we'll take that in a further lectures. Okay. So first of all, we need to understand why need to understand the slope area. Okay. So as it's the habit of this class only that the questions will be asked and then it will be answered. Okay. So over here the first question which we raise, that why we need to understand the slope failure. So answer is already given by me in the starting, the introduction of the slope failure only, slope stability only. Over there, I have said at the various slopes failures takes place across the globe, across the country, which lead to huge damage to life and property. So that need to be protected, and to protect that, the better understanding of the slope stability, slope failure control measures need to be have. So that is the need to understand the slope failure. Over here you can see an image in which the flow of swipes takes place. As you see over here, the at the downward section, various constructions are viewable, and these constructions which is visible is the various houses. As you see, okay, I will use the pen or highlighter to show you. I use the pen over here. Over here, you see the various constructions, various houses are here. There are too much houses are constructed over here, as you are able to see, right? So, and the slope are behind that. And as you see over here, also some vegetation work is there, right? Over here you see the vegetation is there. Over here also vegetation is there. But over at this section you can see there is no vegetation at this point of time when this image is taken. So what are the reason that this vegetation get eroded out? Due to the failure of slope, soil mass flows out. These days, when you go across the several news article, or maybe if you are aware about on social media contents over there, you see that some people recorded the slope failure videos and uploaded on their social media or anywhere else. This type of failure takes place. Earlier, this type of vegetation is also over here, which flow out with time due to the failure of slope at this section. And how the failure takes place, which we discussed, that the strength, the amount of stress which is acting at that section is more than the strength of the soil at this specific section. That's why the failure of slope takes place. And as the failure takes place, it draw down the constructions which are established over here. And that will be very much hashed if some people or um, some people are drawn into those things. If some construction are there and some people are established over here, so during the scenario with the slope flows out in this manner, the people stayed over there, draw down into that section. So we need to concern about those people as the civil engineers, geotechnical experts, to protect them. So how the slopes should be protected in order to reduce the chances of damage. Basically, no one can control at the 100% extent because nature always follow their own rule. If you disturb the nature, as you see, it has been said in the several reports that the human activity could also lead to the various disasters. Sometimes this is also the case, but as a human, as a scientist, if you want to control this type of disaster failures, we need to understand the aspects that how, first of all, we need to understand how this failure takes place. Then we need that what are the solution to resist these type of failures which take place across the globe. Again, as you move ahead, you see over here also there are the first, second, third, and fourth images. In the first images as well, you see that the soils are clearly visible at that section. The soil mass flow out. That why the green section over there, the vegetation are visible, is not visible. Similarly, in the figure 2 and figure 3, it is clearly visible that the soil must flow down from that section. That's why over there no vegetation is present at this point of time. So to protect the erosion, to protect the failure, the swipes need to be bounded at section that section. So as a child, when we are a small child, we read again and again that if we plant the tree, we do the plantation, the chances of erosion get reduced. Over here you see that wherever the part visible, the clear soil, neat soil is visible, at that section the vegetations are flown out. From that section only the soil flows that will take the vegetation from there with them. So the failure is clearly visible, and these type of failures are the slope failure of a small extent. Similarly, when we see the previous image in the last slide, we see over here a large slope failure takes place. The large part of the soil section flow out, and the construction, the structures, the establishment which are present over there is also drawn into that failure. So we need to get a understanding about the same. Now see the next. Over here, the India over all topography. You we know in India the plains are there and the different types of soils property is also found across the country, and the slopy terrain are there, the mountains are there, the rivers are there, the plateaus are there. So the different perspectives of the terrain found across the country. So we need to understand our topography in order to prevent. As we see in the Himalayan belt is also there, So the various mountain ranges are there in the Eastern Ghat, Western Ghat, various plateaus. So over there also the rock mass are there, but they are relatively stable. But when we talk about the Himalayan ranges, specifically the state like the Himachal Pradesh or in the various aspects of the northeast states, the states which are connected with the Himalayan region, over there there are too much mountains are there, and the roads construction are made through the by cutting the roads. So over there, if some big failure takes place, some big slow failure takes place, that will lead to the large damage, and they sometimes also block the transportation system through the roadway. So the slopes over there are highly viable to failure. So that's why the slow failure need to be understood by us. As we see, talk about the slope and its necessity. So, an exposed ground surface that stand at an angle beta, be over here written that is beta, with a horizontal is called slope. Obviously, what is slope? The question is that what is slope? Slope is something which make a specific angle with the horizontal. So that angle will be the slope angle, and the phase which make the angle certain angle with horizontal is the sloping phase. And we construct the highway and the railway, embankment, earth dams, bridge and canal across them. As we talk about the types of slopes, as I already so said that infinite and finite are the two types of slopes. When we talk about infinite slopes, they have a dimensions that extended over the great distance, and the soil mass is inclined to be horizontal. As you have seen in the first image, the angle beta has been shown which is equal with the horizontal, and the vertical slice which has been shown over here is also presented to you. The inclined surface is the sliding surface, and the resistance force is applied in the upward direction. The slope is trying to move in the downward direction, and the face which is inclined is said to be failure phase, sliding surface, and these are the infinite slope. They have a large length across their cross sections. That's why they are said to be a infinite slope. Similarly, you see the second image in which a finite slope is presented. So the finite slope is one which has a base and a top surface, and the height is being limited. If the height is being limited, then it is said to be the finite slope. If not so, the slope is said to be infinite slope. Over here, mm, the inclined phase of the earth dam, embankment, and excavation and the like are all finite slopes. Now you see the types of slope. So the first is the natural and the second is the man-made. Natural slopes are already established, already present across the country, across the globe, and the formation that takes place due to the geological feature of the earth that is not associated with the human or the mankind activity. When we talk about the man-made, the construction activity like cutting and filling, during the construction we sometimes cut out some section or fill the soil at the other section to make a specific inclination to make the construction practice easier. Over there, the slope get constructed, and that slope is said to be the man-made slope, and that takes place due to the cutting and filling activity. Now, we talk about why to understand the slopes. So, the failure of natural slopes, landslides, and the man-made slopes has resulted in the loss of life and destruction. It will also lead to huge damage to the property as well. In the same aspects, it also affect the vegetation's habitat of the people as well as the animals also who are present over there. So the understanding of slope need to be. very much viable hormone and all, specifically for the technical person like us. Now, we talk about the civil engineers are expected to check the safety of the natural and the slope of excavation because we civil engineers are keen to know all the things which are associated with the construction practices, establishment, and the reconstruction, redistribution of forces. Everything is thing to be known by the civil engineers, right? Okay, so now you see the slope stability analysis consists of determining and comparing the shear stress development along the potential rupture surface with the shear strength of the soil. Attention has been paid to the geology, surface drainage, groundwater, and the shear strength of the soil in accessing the slope stability. Now, when you see the slow failure triggering mechanism, so there are the some of the mechanism which will lead to the trigger the slow failure. The first one is the intense rainfall, as we know, and it is already found, it is already said in the various reports as well that when the rainfall takes place, the water table get rise uh, not only in the plain surface as well as in the mountainous region that will lead to create of the poor water pressure and which will result in the decrease in the effective stress. As the value of effective stress get reduced, it is a high chance to be create a trigger of failure, trigger a reduce in the shear strength. As the pore water pressure increase, the value of effective stress get decreased, and if the value of effective stress decrease, subsequently the shear strength of the soil at a specific section also get reduced. In that case, the slow failure may trigger. Subsequently, the water level change, as it has been discussed that during the rainfall, the water table get rise up. As the water table rise up, the pore water pressure increase. Subsequently, the effective shear stress, effective stress get reduced, and similarly resulting in the reduction in the shear strength of the soil. Seepage water flow is also associated with the rise of water table, so that one more additional point that trigger the failure of the slope. Now, the volcanic eruption. This is not the practice not associated in general because volcanoes, active volcanoes are not present all across the globe. So this is a limited point which will lead to the failure of the slope or trigger the failure of the slope. So the volcanic eruption is also a case if the volcano are present at a specific section and if eruption takes place, that may, that must, or that is one of the point which could trigger the failure of slope. But this has a very limited condition because the active volcano are not present all across the globe. The next one is the earthquake shift. Now, this is the one of the most important signal because when the vibrational forces transmit through the slopes, it will result if in the liquefaction as well at some point of time if the soil property are susceptible for the liquefaction at that specific section. Because it has been said that our Himalaya is not made up of the big rocks. Their soil property are too much inherent. That's why the chances of liquefaction, specifically when we talk about the our mountain Himalaya range, about that mountain. The next one is human activity. As it is said that in nature, everything, if we try to extract, if you try to harass the nature, nature will also harass you in one way or the other. So the human activity, if the human activity keen to damage the environment, like the we cut down the tree, we make the flow of water to be restricted, so nature will also punish us in a same manner. So that is the one of the aspect that we need to be taken care of in order to control those type of failures. Now we talk about the cause of slope failure. So the first point related to the cause of slope failure is erosion. And in erosion, we say that the wind and the flowing water causes erosion of the top surface of slope and making the slope steep and thereby increase the tangential component of driving forces as we see, the second point, the second cause which is mentioned over here for the failure of cause of the failure of slope is the steady seepage. So the seepage forces in a sloping direction add to the gravity forces and make the slope susceptible to instability. The pore water pressure decrease the shear strength. This condition is critical for the downstream slope. The next one is the sudden drawdown. In this case, if there is a reversal in the direction of the flow and result in the instability of the side slope. Due to the sudden drawdown, the shear stress are more due to the saturated unit weight, while the shearing resistance decreases due to the pore water pressure that does not dissipate quickly. So in that condition also the slow failure takes place. So this is one of the most important key cause of the slow failure. Next one is the rainfall and the problem associated with the rainfall we already discussed. Over here it is mentioned that the long period of rainfall saturate, soften and erode the soil's water into the existing cracks and may weaken the underlying soil layer, leading to the failure. For example, the mudslides. Right. Now, as we move ahead, the next point is the earthquake. They include the dynamic shear forces. In addition, there is a sudden buildup of the pore water pressure that reduces available shear strength. The external loading is one of the important causes in which the additional loads are placed on the top of the slope that increases the gravitational forces and may cause the slope to fail. The one of the most important is the construction activity at the toe of the slope. If some construction takes place at the toe of the slope, for that the excavation takes place at the bottom of the sloping surface will make the slope steep and they may increase the gravitational forces which may result in the slope failure. As you see, the slope failure, phase failure, base failure, toe failure. So some of the important types of failure is presented. If we disturb the slope specifically at the toe section, over there the soil property get affected and it weakens that section lead to the flow of soil from there resulting in the failure of slopes. Now you see the some of the key terms uh, associated with the slope failure. So over here you see the center of rotation is presented, then the crest of the slope is variable, toe of the slope you can see in the right down bottom, slip or the failure surface, the sliding mass and the slope, everything is visible to us. Now you see, give me a minute, I will be back in a minute. Excuse me for a minute. Yes. Okay. So what I am talking about, like as you see over here, the some of the key terms are presented in which we have seen that the crest of the slope, toe of the slope, the center of rotation of the slope. So over here, the theta is the angle which you see make between the crest and the toe of the slope. Similarly, the slip failure the slip or the failure surface is visible, the sliding mass is visible, slope is visible, and the angle of the slope beta is also visible clearly to all of you. Now we see the definition of this key term. So first is the slip or the failure zone. Now it is a thin zone of a soil that reaches the critical state or the residual state and result in the movement of the upper soil mass. Over here, the soil mass move toward the downward direction resulting in the failure of the slope. When we talk about the slip plane or the failure plane or the slip surface or the failure surface, it is the surface of sliding which is also visible over here. You can see the slip or the failure surface is this surface. The sliding mass is this one which we have already going to see right now. The slip or the failure zone is the zone in which the failure is going to take place. Now we talk about slip sliding mass. So it is a mass of the soil within the slip plane and the ground surface. Next one is the slope angle. So this is the angle of inclination of the slope to the horizontal. And the next is the slope angle is sometimes referred to as the ratio, for example 2 ratio 1, that is the 2 horizontal 1 vertical for this case, right? Now we talk about the type of failure. As I have already said this point only. So over here it's again said that the mainly the three types of slow failure we have classified. First is the phase failure, second one is the toe failure, third one is the base failure. In a phase failure, the failure takes place from the phase toe to and base. Okay, we will see some images. Over here, first one is a phase failure. In a phase slope failure, in this type of failure, when the slope angle is large and when the soil at the toe portion is strong, in that case, the failure takes place from the face only as the slope soil mass throughout from that section. So this type of failure to be phase failure. One most important aspects about this type of failure is that the soil at the top portion is strong relative to the face, that is AB. As we have already said, the failure phase in a very third or fourth slide when we start the slope stability. Over there we see. So this is the one of the most important aspect which we have seen over there. Now we talk about the two failure. Two failure over here you see that the soil face at exactly from the toe section and the failure arc is already drawn. So in this case the failure surface passes through the slope. This occurs when the slope is steep and homogeneous. Yes, if the slope is steep, then only it is a high chance that the slope fails from the toe section only. Now, the third one is the base failure. In this case, the failure surface passes below the toe. This generally occurs when the soil below the toe is relatively weak and soft. Now we talk about the analysis of the slope or the factor of safety. So the factor of safety of a slope is defined as the ratio of average shear strength of a soil to the average shear stress developed along the potential failure surface. The Fs is said to be tau f by tau d, where tau f is the average shear strength and tau d is the average shear stress which is developing along the potential failure surface. Now, when we talk about that shear strength, so that shear strength of soil is given by C plus sigma tan phi, where C is the cohesion, sigma is the normal stress on the potential slip surface, which we have discussed in the last slide as well when we talk about TOF, and the phi is the angle of internal friction of the soil. Similarly, for the mobilized shear stress, this value is given by tau d equal to CD plus sigma tan phi d, or tau modified equal to Cm plus sigma tan phi m, and in the above equation CD and phi d are the cohesion and angle of internal friction that are developed along the potential failure surface, and so the value of Fs is given as C plus sigma tan phi upon CD plus sigma tan phi d. Now, when we calculate the factor of safety with respect to cohesion, we say Fc equal to C upon CD, that we are taking C divided by mobilized cohesion. We say the factor of safety for that case. Similarly, the case which will be followed for the friction angle as well, which we state as tan phi upon tan phi d. Right? I think so. I'm clear. Okay, so there will be no problem. Again, as we say that Fs is equal to Fc equal to F5, so when Fs equal to 1, then the slope is said to be state of failure, because at that point the slope is at the verge of failure. Now slope is going to fail anytime soon. So that is the case which arises when Fs equal to 1, that is factor of safety is 1, and that is the condition in which the slope is going to fail anytime soon. When we talk about the finite slope analysis, so a finite slope is 1 with a base and a top surface, the height being limited, and the inclined phase of the earth dam, embankment, excavation, and the like are the all finite slope, because over where the depth is limited by us, and that will be mostly made by the human activity by cutting and filling only. So the inclined faces of specifically earth dams, embankments which are constructed, are the finite slopes. Now, when we talk about the investigations of the stability of the finite slopes, involves some of the following steps. Like first is assuming a possible slip surface, then studying the equation of forces acting on this surface, then repeat the process until the worst slip surface, that each one with the minimum margin of safety is found. Now, the when we talk about the analysis method for the finite slope, so for the finite slope, the methods are Swedish circle method, which is also said to be arc method, or it can be stated as the method of slices, the standard method. So these are the some of the name which has been given to the Swedish circle method. The second method which is used for the analysis of finite slope is the Bishop simplified method, which is also a part of the method of slices only. And the next one is the Taylor stability number. We go across one by one for all of them. Now, you see, we talk about the Swedish method of slices for a cohesive frictional C5 soil. Okay, so this method is specifically used generally for the type of soil which has the combined gain of C and phi. When we read this sentence, this convey that the soil might also have cohesion as well as angle of internal traction, so that soil is neither only the clay soil nor only the sandy soil. For that type of soil condition, the Swedish flip circle method is performed. Okay, so when we see this method, we came to know that we came to know that the in this type of soil is said to be C5 soil, and for a C5 soil, the undrained shear strength envelops so both the cohesion and angle of internal friction. Obviously, and we have read this in the triaxial test things over there. We plot those the same, and the total stress analysis can also get it. Okay. Now you see, over here, the slip circle are divided into number of slices. And this number of slices we can adopt as the number of slices and the width of slices is less, as the number of slices are more accurate the result. As you see the free body diagram for a small slice which is taken from the figure which representing the slip circle divided into slices. From free body diagram, one can see the width of the slice is shown as B, depth of the slice is presented as Z, and the normal force which is acting, the weight which is acting, and the slope which make with the horizontal, everything is presented. R1 and R2 force which are acting along the slope failure surface is shown over here. The W which is acting in the downward direction, and when we see the normal to the failure surface is represented as N, and the angle theta is also presented for the same. Now we see the calculation associated with the same. So the in procedure, first of all, draw the slope to the scale. First of all, the slope should be drawn, specifically maybe on some of the drawing sheets. And in that, a tri-slip circle set AB with a radius R is drawn from the center of rotation O. Then divide the soil mass into the slip surface in a conventional number of slices, and slices number should be more than 5. Depending on that, the width of slice is taken, and then determine the area of the each of the slices and name them as A1, A2, A3, A4, A5 and so on. And the area which we are going to calculate for the each of the slices is calculated as the width of the slice which we have fixed into the height mid height. If we take a specific slice like this, let me show you with the help of pen. Suppose this is one slice, and we know the width may be 1, so we need to take, this is a slice, then the height, this the section, the edge at the middle of this section is said to be height of that slice, which we are going to state for our calculation. So for determining the area of each of slice A1, A2, AN, A is the width of the slice, that is say width of the slice is said to be B. This much is the width of the slice, which is said to be B, and the height is said to be H or Z, which maybe you want to present, right? So in that manner, we find the area of each of the slices. The minimum number of slices should be 5 or above. So depending on that, we calculate the area of every slices. Now determine the total weight W, including the external load, if any, acting on these slices. So the W, the self weight is found as gamma into B into Z, that is gamma into area, as we have calculated A1, A2, A3, A4, AN. When we sum up them, we find the entire area as A, and when we multiply gamma and B, specifically the B into Z is a B into Z is the A1, A2, A3. B into Z is A1, A2, A3, and when you find the A1 and you multiply it with gamma, you find the W1. Similarly, doing so, you find the entire weight as well. Now, over here, the gamma is the unit weight. I don't think I need to explain this. B the width of the slice, and Z is the height of slice. How I have already explained. Now, the reaction H1, H2 on the slides of the slice are assumed equal and therefore do not have any effect on the stability if they are as they are equal and opposite. Now, the weight W on the slice is set off at the base of the slice and the direction of its normal component N and the tangential component T are drawn to complete a vector triangle. Now N is stated as, which is shown in the figure over here in the downward direction, down right. W cos delta and T is said to be W sin delta. The value of N and T are scaled off for each of the slices. The values of N and T are tabulated and summed up as shown in the following. The factor of safety is calculated as follow. First of all, we calculate the sliding moment, then we calculate the resisting moment. The sliding moment is calculated as R into summation of T, that is said to be reckoned positive if clockwise, and then the restoring moment is said to be R is equal to C R theta plus summation of N tan phi, if positive if counterclockwise. So the Fs is said as C R theta plus summation of n tan phi upon summation of t. In this manner, we are able to explore, we are able to develop a relation to find the factor of safety for a slip circle method or the Swedish slip circle. Right? I think so. Thing will be clear for everyone. Yes. Yes. Now, how you create a solution? So over here, the symbolic table is also represented. First of all, we have make the slice, divide into slice. The slice number should be 5 or more, at least 5. So slice number is mentioned over here. After that, you calculate, you have known the width as you have decided the number of slice or maybe divide into equal width, or it is common assumption to divide in the equal width. So you know the width, you calculate the height at the center, and as you make the trial slip circle, so you calculate the area. Afterwards, you multiply the area with the unit weight, you find the weight. Now you have to calculate the W cos phi. W is known, so the W cos delta and the W sin delta is calculated, and their sum is taken care of. Afterwards, you are able to use the this equation to find the Fs, and if Fs is less than 1, repeat the step to 2 to 9, in which you consider the another slip surface, again divide in the different number of slices, and by considering the various trial slip circle, you are able to calculate the Fs for each of these slip circle, and the slip circle with the minimum Fs is called the critical slip circle. So in order to do so, repeat the process and again till a minimum value is reached, so that you can say this is the critical slip circle. Now, the critical slip circle is the one through which the failure takes place, as we have seen earlier, as we have understood during the shear strength as well, that this much needed to be the strength over there. If it overcome that value, the failure takes place. Now, we move to the second method for the calculation is the Bishop simplified method. This is the Swedish circle method ignores the rotational failures of each of the slices but consider overall moment equilibrium. But in the case of the Bishop method, the equilibrium is considered for all the forces at each side. So over here again you see the B is the width of the slide, normal to the failure surface is and W is the weight, and the theta angle is also presented. R2 and R3, R1 and R2 is also shown. So in that case, this in this manner, this is different from the CD circle method. Now we move toward our next venture, that is said to be Taylor stability number. So in a slope stability, the component of the self weight is the gamma. Basically, the self weight is due to the unit weight of soil. The unit weight of soil is acting as a weight in a specific direction, and the causes instability and cohesion um, contributes to the stability exactly as we have said. So the maximum height HC of the slope is directly proportional to the unit cohesion Cu and inversely proportional to unit weight gamma. In addition, HC is also related to the friction angle phi u and the slope angle beta. So this can be expressed as HC equal to Cu by gamma, that is multiplied by the function of phi u and beta. So when the term f phi u dash beta is dimensionless, then the equation is dimensionally balanced. So the Taylor in 1937 expresses f phi beta as a reciprocal of the dimension of the number called the stability number Sn, popularly called as the Taylor stability number, which is function of phi and beta, which is stated as 1 by Su. And by using this stability number, Hc is said to be Cu by gamma Sn, and similarly, if we able to find the stability number, which is said to be Cu upon gamma h. So, in this manner, the Taylor stability number is calculated, which is useful for the calculation of the finite slopes surfaces. Now, we move to the infinite slope analysis. In infinite slope analysis, the slope stability of the earthen dam for the different conditions are understood. So in the infinite slope, as I already said, their length is very high and the slope angles are also not too much keen. So the slope stability for the earthen dam for the different conditions, the infinite slopes have dimension that exerted over a great distance and the soil mass is inclined to the horizontal. If the different strata are present, the strata boundaries are assumed to be parallel to the surface. Yeah, some assumptions are also over here for the infinite slope calculations. So one of them is that the different strata are present, that the strata boundaries are assumed to be parallel to the surfaces, and the failure is assumed to occur along the plane parallel to the surfaces. That's why the above assumptions are there. Now you see the salient planes are presented and the sloping surfaces are presented. So as per assumption, the sloping surfaces are parallel to the failure surface, and this plane make an angle beta with the horizontal. The Z1 and Z2 two heights are also presented. So when we talk about the analysis case, so three case may be arrived. First is the cohesionless case, that is the soil is the sandy soil. Second is the cohesive case, and third is the C5 case in which the cohesion as well as the angle of internal frictions are there. So when we go ahead and we talk about see that we see that the infinite slope in the cohesionless soil. So first of all, consider an infinite slope in the cohesionless soil inclined at an angle to the horizontal as shown. Consider the element A, B, C, D. Over here you can see the image in which the small b, small c, small d section is variable. Over there, this may be acting as slice. Over here, the W is acting in the downward direction. Now, consider a case in which over here the image is already shown over here, in which the weight of the element be W and the component of W parallel to the slope is said to be W sine beta. Uh, Yes, because beta is the angle made by the slope with the horizontal, so the component of W parallel to the slope is W sine beta, and the component of W perpendicular to the slope is W cos beta said to be N. And the force that causes the slope to slide is W sine beta. That is the component of W parallel to slope, because the slope is moving is said to be flow said to fail along the slope direction only.
So the force that resists the sliding or the slope is sigma tan phi, that is equal to n tan phi, that is equal to w cos beta tan phi. To calculate the factor of safety, we have to do a calculation that we divide the resisting force by sliding force. In this case, the resisting force is W cos beta tan phi and the sliding force is W sin beta. When we perform our calculation, the W is cancelled for each of the case and the tan phi and tan beta we are came with the end of our calculation. Now, by applying the concept of the limit equilibrium, under the limit equilibrium, the Fs is equal to 1, tan beta is equal to tan phi, hence beta is equal to phi. So, the maximum inclination of the finite slope in a cohesionless soil for the stability is equal to the angle of internal friction of the soil. Right. Now we see some of the more cases. First is showing the limiting angle of inclination for the stability of an infinite soil in a cohesionless soil is shown over here. Over here you can see if beta is less than phi, the slope is stable. The second, if beta is equal to phi, it is a limiting case, and if beta is greater than phi is the angle of internal friction, beta is the slope, then it is said to be unstable. And the beta, the stable is the slope, and phi, the limiting condition is presented. More Coulomb strength envelop and unstable slope condition, everything is shown in the figure given here. Now we see the infinite slope in a pure cohesive soil. Over here, the height of the slice Z and the width of the slice B is clearly visible. The N, W, and the beta, everything is represented. Now we see for the normal stress on the failure, sigma is N by L multiplied by 1, and cos beta is equal to b by 1 by b by l from the previous case, and similarly that is for l is equal to b by cos beta. Now sigma n is w cos beta upon b by cos beta, that is equal to w by b cos square beta when we do our calculation, and that ultimately become the capital W cos square beta. Now the shear stress toddy is T by 1 into 1, that is equal to W sin beta upon 1 into 1, that is equal to W sin beta upon B by cos beta, and by performing our calculation at the end for the cohesive soil, we came to the equation in which we calculated tau f by tau d, which is came to be C by gamma z sin beta cos beta, which is the factor of safety for the cohesive soil case. And at critical condition when Fs equal to 1, Zc equal to C by gamma sin beta cos beta, and for the given case slope Zc is directly proportional to the cohesion and inversely proportional to unit weight, and C by gamma Zc is a dimensionless quantity called the stability number, that is Sn equal to C by gamma Sc or C by gamma Z, whatever we want to state, right? So, in an infinite slope in a cohesive friction soil, Fs is given by C plus gamma z cos square beta tan phi upon gamma z cos beta sin beta. That is the shear strength by the shear stress, which is the basic definition to calculate the factor of safety for the infinite slope. So we are able to find the interrelation which is used for our calculation for the factor of safety in a cohesive soil. Now, with this, we will sum up the today's session. So, some of the references which I have used during the construction of the material for this class. So, you can refer the same, and I will suggest to go across the slope stability class of the SAR as well, and try to solve some problem related to the same. As we are discussing the concept only in this class, and some points more I will discuss in a next class that is going to take place on Monday, and at the end we will going to solve some problem as well in that class. So be there, and I will suggest you to solve some problem, and some books are mentioned over here. Apart from that, the reference are also provided in the course content of geotechnical engineering 2. I will suggest you to solve some problem, and as we have read the anchor bulkhead and some case study I will present it. So you can go across those and see that the how bulkhead application takes place in their Panama Canal and the diamond or something. The two more examples are there. You can see the physical example in which the bulkhead application are clearly viewable. So I will suggest you to solve some problem, and with this I will sum up this today's session. Thank you everyone for joining. We will meet again on Monday. Thank you very much.